Hello everyone, my name is Joshua. It's my pleasure to welcome you to Echo Software Consulting Training Workshop. And we want to look at quite a lot of things in this workshop. We want to consider handling missing observations. It's a comment, so let us add the arch symbol there. Data manipulation. Simple hypothesis testing. Correlation and regression analysis. Let's set the ball rolling by loading packages. Library, we need mice, MICE, for adding the missing observations. Tidyverse for manipulating the data set. Library labeled for labeling the variables. Library VIM for visualizing the missing observations. Library rempsyc for publication ready tables. Library smart EDA for getting the overview of the data and structure, and some exploratory data analysis that you may want to look at. Library Hasna. Also for simple hypothesis testing, in a way that it could be exported to Microsoft Word. Then we need library flextable, as well as stargazer. For publication ready tables of our output in an exportable form. So let's run all the packages. Run. All right. So let's set our working directory and import in data.csv data. Go to session, set working directory, choose directory. I'm using the 3 folder as my directory. Let's get the content of the folder. So click on file here. So these are various documents in the folder. So let's import in data. This is the data set. Click here, import data sets. So import. Okay, so now that we have imported the data set, now we can move straight away to handling. Let's start with handling missing observations. We must first know some of the problems that we have. We must know that we have the missing values, that is the starting point. So there are two quick methods to do that. We can obtain the quick summary statistics. To do that, just type summary. Summary in data. So run. So a quick view of the summary statistics show that for RD, which is investment in research and development, one stands for firms that invest and two for those that do not. There are 80 missing observations. For the cost of materials, that is cost of intermediate inputs, mat cost, it's 1,944 missing observations. Machine cost, which is the big book value of machinery, 2,610 missing observations. Cost of building, which is book value of building, we have 2,583 missing observations. Labor, which is number of employees, we have 112. Ownership of websites, 43. Year of establishment of industries or firms, 248. The use of email, we have 39 missing observations. Ownership, whether it's domestic or foreign firm, 194. Legal status, 69. So, and even the sales, we have 527 missing observations. So we have a lot of missing observations to deal with. So another way to show the overview of the missing observations or the data sets, let's get the overview. So overview of in data. So we have XP data. Okay, let's give it a name. Let's say in data underscore OV, not 0V, equals EXP data in data, comma, type equals to 1 for the overview. So let's run this. And let us get the results into Microsoft Word. So we have stargazer in data underscore OV, comma, type equals HTML, comma, summary equals F. Then out equals as the name of the output. So let's call it in data underscore ov dot doc document. So let's run this. Okay, cannot open, it means we have, so let's say OB1. Maybe we have another document with that name before. All right, so now just double click on this to update. So let's look for in data low view 1. This is it here, so click. Yeah, so here we have the results. So we have 2,676 observations, 14 variables, and we have just 21.43% of the variables with complete cases. So we have massive proportion of missing observations. So let's go back to our R here. We may look at, there's another thing we can do. Another way to look at the overview of the data is to look at the structure. Let's look at the structure of the data. Data structure. It provides a clearer picture. So we have, let's say, in data underscore, let's call it S equals exp data in data type equals 2 this time around. Run. And let's use stargazer to move the research to Microsoft Word, paste. So let's change this to S. Let's change this to S. So let's run. So, and let us update. Okay, it's already there, so good. So now we have more information. So for sales, for instance, now we have the number of missing observations to be 527. The percentage is 19.7. For size, we don't have any missing observation, but we have just 4 distinct values. There are 4 distinct values: 0, 1, 2, 3. 0 for micro, 1 for small, 2 for medium, 3 for large scale firm. By the way, I think I should just say this. The data is extracted from World Bank Enterprise survey. I think that's a 2013 survey. Data is for Nigeria. And it covers 2,676 firms. So we have, and if you scroll this down, for instance, let's look at bidding costs, matching costs. You can see that we have more than 95% missing observations. So we have quite a lot of problem with missing values. So how do we handle these missing values? And that should be the next thing we want to quickly look at. So let's go back to you may wish to just delete listwise deletion, or delete all the missing values. And if that is what you want to do, let's do it so that at least you will see the limitation and the reason why it may not be the best option. So let's call it in the term underscore, let's say GL equals CC, CC in data. Run. Okay, so and let us get the structure. To save time, let us just copy. Let's copy line 29. Copy. Paste. So this will be DL. So it will be DL. Yeah. So let's run this. Object DL not found. So we have not run this. Okay, so let's run it. In data underscore DL. Sorry, it's underscore here. Run. All right. So and let us use stargazer to move the result and look at the reason why it may not be a good option. Copy. Paste. So this will be DLS and this will be DLS. Run. So this is it here. So let's look at the results. Yeah, you can now see, yes, we do not have missing observations, but if you look at the sample size, it has reduced from 2,676 to just 41. That is a colossal waste of resources. Think of the time, the money, and the effort invested in collecting the data. So, and a lot of bias will have been introduced by this kind of occurrence. And you know, by the way, this is exactly what happens if you do not do anything concerning the missing observation and use it to run your regression. All the missing observations are actually deleted. And so this is the reason why it is not advisable to go ahead with that kind of analysis. So let's think of better thing to do. So in terms of better thing to do, there is what is called mean imputation, mean imputation method, mean imputation method. For mean imputation method, what happens is that the mean of the observed variables are actually used to replace the missing ones. So for mean imputation method, let us try to do it. Let's say IMP underscore, let's say M1 equal to mice. This is why we have mice package. So mice we have in data. Mice we have in data. Then method equals, the method AL equals to mean. Method equals to mean. So let's run this. All right. So and let us obtain the complete data. Excuse me. So for the complete data, let's call it IMP let's say in data underscore m1 equals complete imp underscore m1. We have 5 different values, but all of them will be equal because this is mean, just calculating the mean. And that is what has been done throughout. So just let's pick one of them. Let's pick 5. So let's run it. Right. So, and let us look at the data set write.csv in data underscore m1 comma. So we have in data underscore m1.csv. So let's run it. Yeah, and let's open it in Excel. That's imp. I'm looking for it. Okay, this in data underscore m1. Yeah, good. Yeah, good. So here we have complete data, no doubt. But if you look at the values, if you look at the cost of building, for instance, this is the mean of the observed values that is used to replace all the missing. The same apply to machine. Those ones may not be problematic, but come to year. The mean value of year was calculated to be 1996.205. That doesn't make any sense. Because it's talking of year of establishment. How do you classify this one? Again, if you look at status, here we have 3.12. The legal status, they are just codes 1, 2, 3, 4, 5, 6. So they're supposed to be integer. I think some of them refer to proprietorship, some to sole partnership, shareholding company, and all sorts of things. Investment in research and development, for instance, if you look at this, supposed to be 1 and 2. 1 for companies that invested in research and development, 2 for those that do not. So it's difficult to interpret 1.8, which is the mean. So that is a very serious limitation. And even if we decide to use linear regression method, we still face the same problem. Because if you are using linear regression method, what you are trying to do is to pick variables with missing observation, then you run it against all the other ones. Because we assume missing at random, we base it on assumptions of missing at random. So then you will obtain the predicted values. So the predicted values are actually used to replace the missing ones. And let us not forget the linear regression also is based on average function. In that wise, we still have the problem. The only difference is that we have different values for the missing values, but definitely you will still have this problem of having maybe 1 point something for in situation where we're supposed to just have integers. So one method that we can use to bypass that problem is the use of classification and regression tree method. In fact, when you are dealing with multiple imputation approach, there are so many methods actually. So, but one of the methods that I've used particularly when you are facing different categories of variables. It's going to help you pick and realign the variables. Maybe, do the analysis based on the type of variables, whether it's ordinal, whether it is nominal, whether it is ratio or interval. So I think that is the beauty of that particular method. And you can read more about it. We just try to focus more on the practicals here. So let us use CAT imputation method. CAT means classification and regression tree. So we have IMP, let's say underscore C equals mice in data, comma, method equals, in this case now, our method will be CART. So let's run it and wait for the results. Yeah. Okay. So now what we can do now is let's get the data. Let's got the data in data underscore C. That will give us, equals complete IMP underscore C. Let's use the fifth inputted value and write .csv. So in data underscore C, comma, yeah, so then the output name in data underscore C dot CSV run. Okay, it's complaining we have, I think we have it before. So let's say C1. Run it. Beautiful. So let's open it here. This in data underscore C1. Import data set. If you look at it here, we don't have, okay, let me open it in Excel because so that we can see clearly what has happened. So in data underscore C1, beautiful. So this is it here. In data underscore C1, beautiful. Yeah, now you can now see that if you, for instance, you may filter this to see what happened. So filter. All right. If you look at it, that's 1, 2, which is what we want. For status, should be 1 to 6. That's exactly what we want, and so on and so forth. So this a nice way to obtain the inputted values. So we can close this. Let's go back to R. So henceforth, we'll continue to use this in data underscore C for all the next level of work we want to do. So, and that takes us to, now that we have a complete data set, then we're going to move to data manipulation, data manipulation, data manipulation. Before the coding, let me show us something. Yeah, very quickly. Anatomy of statistical analysis. The starting point of the work, any work you are trying to do, is collection of the raw data. But my candid advice is that never use raw data for your analysis. You have to subject raw data to data cleaning. So which means you have quite a lot of correction to make technically. And one of them is what we'll be trying to do to make sure that we input for the missing values. There are quite other things to be done, like we'll continue like that now. There are times you may need to rename some variables. You may need to provide labels. You may need to filter. You may need to arrange. You may need to do some recoding, and quite a lot of things to do to be done. Then you need to check for normality of maybe some of the variables to be used in order to control for outliers and so on and so forth. So after you might have done all those things, then you obtain what is called consistent data. So the type of data we normally use for analysis is consistent data. So you use the consistent data to do your estimation and all manner of derivation. And after obtaining your statistical report, then you ensure that it is formatted so that you have it in publication-ready formats. So this is an overview of the anatomy of statistical analysis. So some of those data cleaning and transformation packages, functions, it should be transformation functions, because we just have just one package to handle that. That is tidyverse. That's why we need tidyverse. So rename is rename, recode is recode, select is select. In case you want to consider subset of the data set, then you filter. To create a new column or new variable, you mutate. Sometimes we need to sort in ascending or descending order. You use arrange. And sometimes we need to group by before you summarize and obtain your summary statistics. You may need to obtain some counts in terms of maybe you want to plot some frequency charts and so on. So these are some of those things, and that should take us back to R. So let's begin to consider them one after the other, for instance. Okay. Let's start with renaming. Let's start with renaming. Renaming variables. To do renaming, you must first know the old names in data underscore C this time around. So yeah, we have sales, size, industry, and lots and so on. So let's do some few renamings. Let's say we want to rename size as firm size. And we want to rename web as web on. We want to maybe remind ourselves that the variable means ownership of a website. Let's say we want to rename label as employee, so that we come to terms with what it means as number of employees. Okay, let us play around with few. We have in data, underscore c equals in data underscore c. Then we have the pipe operator percent greater percent, which is what links in data underscore c with the next we want to do. In layman language, it means then. What I want to do is renaming. So just say rename. So don't forget this. It is new equals to old, not old equals to new. Take for instance, we want to rename size as firm size. The new name will be firm size equals size. Simple. And let's say we want to rename label as employee. And let's say we want web. Sorry, you can say, okay, let's say web on. That's the new name equals to web. So let's say this just the three variables that we want to rename. So let's run it. I think we have EU with. Oh, sorry. Yeah, you see, I miss it here. You can see it should be employee, which is the new name. Yeah, it's even good that I made a mistake because to labor, you know, is a common mistake. So please, it is new equals old, new equals old, new equals old, not old equals new. So now it will work. Beautiful. So then run names again. You can see that our size has been replaced with firm size, then the web with web on, then label with employee. Those are just the three that we touched. So that is how to do renaming. That takes us to the next one, select. To select variables, sometimes, no, in this case now we have 14 different variables. It's possible we don't need all of them in our analysis. So let's say we want to extract variables that we may need for regression analysis. For instance, let's say reg data equals, we are getting it from in data C, then pipe operator to link us to what we want to do. Then we have selects. So we select, let's say we need sales, we need firm size, let's pick few. We need bid cost. Okay, we need employee, definitely we need employee. Let's say we need email, web on, bid cost, match cost, and let's say match cost. Okay, let's say this is just what we need. So let's run this. And let's look at names. Reg data is run. So we have succeeded in reducing the number of variables to just 8. Yeah. So that is how to you select filter. Like I said earlier, use filter to obtain subset of the data set. We have 0 for micro, 1 for small, 2 for medium, and 3 for large scale firm. Let's say we just want data for small scale. Let's call it SC data equals, we want to get it from in data underscore C. Then you have your pipe operator here. Then you see filter. Now we have filter for mice, but the filter we need is for dplyr. So in order not to confuse the functions in mice with that of dplyr, which is that package in tidyverse that we are using, you will type dplyr, you pick it. Then you say filter. You can see now. So this is clearly showing us that this filter function belongs to dplyr package. So, and frame size equals to 1. That is for small scale. Run. You may want to check, that's head. Let's say you want to check the first 6 observation. Run it. So look for frame size. You see everything will be 1, 1, 1, 1, 1, 1. Let's see. You can extend this to something like, let's say, the first 15. Check again. It's going to be 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 throughout. In case you want to look at the last 15, for instance, still run it. It's still going to be 1, 1, 1, 1, 1 because we're just dealing with, you can see clearly. So that's how to do it. But let's say I need 1 and 2, for instance. Let's say I need SME data, for instance. So let's say I need data for small and medium. So again, you have dplyr. Then you have, you can actually scroll down to where you have filter. It's not going to waste too much time. Filter, yeah, that's it. Just pick it here. So in this case, you have your frame size. Oh, sorry. We must first, that's in data, because we have not underscore C. We have not indicated percent greater percent. Yeah, exactly. So, because we want to obtain it from in data underscore C. So filter, frame size, that's why it's not coming out the other time. So we have frame size. In this case, you use percent in percent. Percent in percent means within. So it's within 1 and 2. So that's it. Good. So again, you may wish to look at edge SME data. For the first 6 observation, everything will be 1 and 2. You can also get, you can see It's either 1 or 2. You can't get 0, you can't get 3. Let's do it for maybe the next 20 observations. Everything will be 1 and 2. Yeah, you can see clearly. Frame size, you can see. It's 1 and 2, 1 and 2, 1 and 2, 1 and 2. So you may wish to look at the last 20 observation tail. So also that one will yield 1 and 2, 1 and 2, 1 and 2. So beautiful. Yeah, so this is the way to obtain subset of your data set. Good. And that takes us to the next thing, which is arrange, that is sorting variables. So we may sort in ascending or sort in descending order. So let's do that for sales, for instance. We have, so in that wise, we have in data underscore C equals in data underscore C percent greater percent. You just say arrange sales. So run. You may wish to look at the 4 6 observations to see the way it is arranged. So we have edge in data underscore C dollar, since we are dealing with just sales alone. So it's going to give us the list of all the variables. So run. You can now see that this is arranged in ascending order of importance. If you want it arranged in descending order, so let's say sorting variables in ascending order. So if it's in descending order, so let's say we have sorting variables in descending order. So to sort variables in descending order, again, let's just copy this to see. Okay, let's type it in data C equals in data underscore C pipe operator percent greater percent. So you have arrange. So in this case, you have DESC, you pick it, sales. So let's run it. So again, you can run the head in data dollar whatever here. You have seen it now. So in this case, it started with the largest value and like that in descending order. So this is the way to sort variables using functions in dplyr. So we move to recoding. So let's move to recoding. So recoding of variables. So we want to recode variables now. Let's get the names of our variables so that we know what we are trying to recode. So we have in data underscore C. So let's run it. Fine. So now let's say we want to recode. Let's start with our frame size. So in this case, we have in data underscore C equals in data underscore C, then greater percent. Mutate is the function for, now again, we have mutate in ggpubr. That is not what we want. The mutate we want is in dplyr. So again, dplyr dot. So we need mutate. Let's check for where we have mutate. So this is mutate that we want. So mutate frame size comma, yeah. So okay, wait, let's do it in a neater way. Mutate equals recode, because we're actually recoding. Mutate equals recode. Yeah, then let's drag this down here. So what are we trying to recode? That is, please take note of what we are trying to do. Mutate, this is the name given to it. What are we recoding? We are recoding frame size. Yeah. Comma. You see, the reason why we maintain frame size and frame size here is that we want it to overwrite what we have in the data set. In case you want to retain your frame size and create another name, this is an opportunity. You can actually call this one frame size 2. If you still want to retain the previous one with 0, 1, 2, 3. So, but if not, this is what we have to do. So let's say we just want to overwrite. So I say recode the frame size. Look at this symbol. We have 0 equals, like I told you, 0 means micro. Okay, comma. 1 equals, 1 is small. Then we have 2. Sorry. 2 equals small. And 3 equals large. They should be in quotes. So this is how to handle that. Then it's better to just continue, so that, let's say, greater percent. Let us recode status. So to recode status, we say mutate. Okay, say mutate, so that's dplyr mutate. Again, what we want is status. Status equals recode. Pick the recode here. Come here. So what are we recording? Status, comma. So 1 equals shareholding company. Share. Okay, let me start with capital here. Shareholding company with traded shares. Traded shares. Let me move this a little bit so that we can actually see clearly what we are trying to type. Comma. Two, sorry, should be inside there. So 2 equals shareholding company, shareholding company with non-traded shares, non-traded shares. Then 3 equals sole proprietorship, sole proprietorship. I hope I got the spelling correctly. Comma 4 equals 4 is partnership. Then 5 equals limited liability. Limited liability. Okay, limited liability company. Or let's say limited liability partnership. That is the meaning. Then 6 refers to others. 6 equals others. Beautiful. Okay, so let's move this here. Again, percent greater percent. Let us mutate ownership. So we have dplyr mutate own equals recode no, this is a bit different. Yeah, mutate, yes, because it's not just categorical, because this is continuous. We have, if you look at the data sets, you can quickly look at in data here and look at what ownership. Ownership is 50, 100, 100. It's in percentages, so it's continuous variable. So let's go back here. So in this case, we use, let's say, own equals, we use if else. If else, because we want to classify them into if else. So we need this if underscore else, that's for dpyr. Own greater than 50. That is, if you own more than 50% of the shares, let's say domestic firm, because that is, yeah, that is if maybe the shareholders, 50% of the, if 50% of the company shares are owned by locals, then it's a domestic firm. If not, it's a foreign firm. So that is just the classification. So here, say domestic. Yeah. Anytime you use if else, you don't use if else for the last alternative. Since we have to, if it's either greater than 50 or less than 50, less than 50 is foreign. So greater than 50 is domestic. So anything less than that will be regarded as foreign. So you just put foreign here. You don't put if else again. So this will be foreign. Yeah. Let's move it a little bit. Okay. Percent, greater percent. So let's continue. Let us recode email and web. So dplyr mutate email equals, in this case we use recode because it's just 1 and 2. Recode. So what are we recording? We are recording email, comma. So we have 1 equals yes. That is, I'm using. Then 2 means no. Okay, it should be in quotes. No. So let's move this here. So let's I think everything, let's check whether everything can be in that line. Yeah, beautiful. So we have percent, greater percent. So let's have that of web. So we have dplyr mutate so we have web own equals recode that's web own comma, so we have Again, 1 equals yes, and 2 equals no. So let's say percent greater percent. Yeah, I want to see clearly what we've typed, so let me move this here. Okay. What more? Now let us generate labor productivity. Let us just use a sales over labor, that is maybe performance of labor. So we have mutate. Oh, sorry, that would be dplyr mutate. Let's call it labor productivity. LP equals to our LP in this wise is labor divided by sales. All right. I hope we have not changed labor. I think we've changed labor to employee. Employee. Yeah, that would have given us a problem. So you have to always remember. Now that's why we got the column names placed on the console. All right. So then let us generate capital. Percent, greater percent. Then again we have dplyr mutate. Let's say capital. Capital is actually addition of the book value of building and machine. Good. Good. So let's run, and I hope we have not made any mistake. So run. So let's run it. Beautiful. So we have successfully generated, we have successfully gone through most of those data cleaning that we need to do. So you may wish to actually store this in a neat, in a very neat CSV format. So let's say write the CSV in data underscore C, then in data underscore, let me say CC, that's it, dot CSV. Good. So let's run this. All right. So then let me reduce the size. Okay, so let's go to, let's move to I think we can now move to D3. So let's look for in data underscore CC. So this is it. So let's open it. Beautiful. So you now see your data set. So you now have your frame size, large, small, micro. You have the status. You have the ownership. You have the email as yes or no. You have the web as yes or no. Oh, we're supposed to actually recode RD too, in case you want to use it, but you can see. But by and large, we have learned a lot, and now you have your data sets in a neater manner. So let's use ID for this. That's actually the ID. And we don't need, okay, wait. This is supposed to be the ID. Yeah. So we don't need this. Delete. Good. So we can actually sort. Let's sort from smallest to largest. Expand the selection. Yeah, beautiful. So now let's save this. Yeah. So it's saving. Yeah. Now it is saved. So now for all the analysis we want to conduct, we'll be using in data underscore CC because that is the updated form of the data set and the most complete. So let's go back to our R. So, and I think, okay, it is still our underscore C here. But in case you want to actually use CC, you can just come here, import it, because you know we have made little adjustments when we get to Excel. So just say import data sets. So let's just import it. Yeah, beautiful. So now we can go back to what we have here. So the last thing I want us to do before we begin to perform some of this analysis, because we'll start with hypothesis testing, but before we get to that place, I want us to know what we have does not have labels. So we don't actually have labels for, so let's say names. So let's names in data underscore CC run. Yeah. So let's say we want to provide labels, particularly for variables that we may want to use for our regression analysis. So let's have here labeling. Labeling variables. So that anyone will immediately understand what the variables actually mean. So let us pick variables that we need for our regression analysis, for instance, and focus on those ones. All right. Okay, let us just rename those ones. I think. Sorry, label those ones. For labeling, you need library labeled and labeled. And the function is set underscore variable labels. This is how to do it. So we have in data underscore cc equals in data underscore cc, then percent greater percent greater percent. Then we have set variable labels. Yeah, in this case you have the names of the variable, then the label. So let's pick sales, for instance. We have sales. What does it mean? Sales is let's say sales, amount of sales in Naira. Yeah. Comma. Let's have frame size. Yes, okay, frame size I think is a bit straightforward. Let's pick something like, okay, let's pick email, for instance. Email equals use of email let's look at math costs equals costs of intermediate inputs let me move it a little bit here to see clearly what I'm typing. Let's look at what other ones. So let's say status, just few, but just to illustrate the usage. So let's say status equals legal status of the firm. Yeah, just to show what they mean. I think that is just the essence, actually. Okay, let me add this. Web on. Web on equals to, this is website ownership. Good. Yeah. So let's say this is just what we want. Okay, we may need, let us add LP equals labor productivity. Okay, so let's say this is just what we want. We can continue later, but it's just to show us how to handle it. All right, so let's run it. Beautiful. And if I want to generate the lists, because sometimes in describing your data, you want to say variable, then the description. I think it's a common thing that we normally do. If you want to do that, it's super clear now that you have set your variable labels. To do that, you just have to say look for, okay, so that we can export it to Microsoft Word. Let's give it a name. Let's say data description, okay, equals that's look underscore for so in data underscore cc details equals to none. So let's see the results. Well, so data description. So you can see, we just so we have the position, the variable, the label. We didn't label the ID. Those ones that we didn't label, they were omitted. But we have sales in Naira, legal status of the firm, use of email, website ownership, cost of intermediate input, so on. So you can work on those on the remaining ones if you so wish. All right. And that takes us to we still have quite a lot that we didn't do. So just let's leave that just to illustrate the use of labeling. So that takes us to the next thing we want to quickly look at, and that is hypothesis testing. Hypothesis testing. So for hypothesis testing, we need Asna library. Asna. So let's run it, because I don't think okay, did we include it previously? I don't know. But it's good at times, because if it's not there, it's going to drag us backward. So let us generate some statistics. So let's call it start1 equals is table by. Let's say we are looking at effect of ICT on performance, for instance, and we have two measures of ICT. We have email, then ownership of website. We may actually want to see the differences in the socioeconomic characteristics based on the use of email or not use of email, ownership of website or not. That could be, in that wise, you understand that it's either you are using t-test or you are using chi-square in terms of categorical variables. So that is what we want to do. So let's have email, for instance, then as a function of So let's say we have firm size plus, let's add status, then plus, can have as many as possible, plus own. I think I hope we did not. Okay, own. Don't worry. That's ownership. Let's say this is just what we want. We can, because these are qualitative variables that we have. Yeah. Okay, let us add plus web owned. This, yeah. Then we have data equals. So our data is in data underscore cc. So run. So we need to move it to Microsoft Word where we can actually picture the answer, the output correctly. So to do that, we have write to, you can see that under as nice, write to word. Write to word. So what are we writing? Start one, comma, file equals, that is the name that we want it to be here. So let's still call this start one. Sorry, it should be in quotes. So that will be start one dot doc. Beautiful. All right. So let's run it. So that generated it. So let's drag this here so that we can look at the output. So this is it here. So you can double click. Yeah. Okay, so I think let us adjust it so that we can see the results in a clearer form. Okay, sorry, let's move this way. Move this way. And let's move this way. And let's move this that we can see clearly. Beautiful. Yeah. One good thing about it is this. You can now see that, we did not provide label for frame size. So that is why we have just the variable name without the label. And this is the use of email. We have 1941 not using, 735 using. The total number of our observation is 2676. So we have frame size, large, micro, and small. And you can see the various percentages. And in terms of the relationship between the size of the frames and the usage of email, we can see the chi-square p-value here, 0.001. And the moment the value is greater than 0.05, we assume 5% significant level. Moment this is less, so we are covered. So since it is less, then there is a very strong association between the size of the frame and the use of email. So and that is why you can go ahead and explain all these differences. Yeah. For starters, we define the we actually define the labels. So that is why you can see it clearly here. So very, very helpful. And it's going to bring it out in both form. So again, if you look at the relationship between the legal status of the firm and the use of email, you can see that there is very strong association. And then you can now explain these differences. Again, like that. This is firm ownership in terms of whether it's domestic or foreign. Again, a very strong relationship. And also ownership of website and the use of email. So we can see that there's a very strong relationship. So that is very, very clear here. So this is one good way to provide a very strong summary of the relationship. Again, we can do it for continuous variables, because these are for quantitative. We can do it for qualitative, but for qualitative, the p-values are derived from t-test. Don't forget that, because that is t-test for either t-test or f-test in case you have more than 3 variables. But in essence, we're just comparing the means. So let us go back here. So let's look at start to, let's copy. So let's copy this. So paste. Yeah, in this case, let us still use email. But now let's say this is sales. And let's say this is labor. And let's say this is capital. And let's say this is plus material. Yeah, good. Okay. So let me move this so that we can see what we're typing. Okay, let's run this. Labor not found. We have changed this to employee. Employee, yeah, I remember. Good. So run it. So sometimes you just need to read. Again, it said material not found. Have we changed that also? So if you have that, I think the best thing is to say names in data CC so that you quickly go through. It's mat costs, not material. Good. So run it. So beautiful. Oh, supposed to I even say start 2. Because we already have start 1. So which means you have to go back and rerun your start 1 because it will have replaced it. So let's start 1. Beautiful. Good. So again, to save time, let us copy this right to Word here. Copy. Have it here. Paste. So this will be start 2. Start 2. Then run. Good. So again, open it here. Yeah, beautiful. So again, you can make all the necessary adjustments here and there. But the most important thing I just quickly want to look at is the p-values. Yeah, so, and in terms of the p-values, here we have the relationship between sales and the use of email, employee, the use of email, capital, the use of email, cost of intermediate input, and the use of email. They are all statistically significant at 5% p-value. So I think that's fantastic. So, and then again, we can now go ahead and check all these differences and explain them based on our understanding of the data sets, and we can now provide a plausible explanation of what is going on based on your knowledge of the data and literature review. Yeah, so this is one way to go about it. So, but there is another thing you may want to actually limit yourself to the t-tests alone. And maybe you want to show the t-test in just the t-test of so many of them in one table, and just the t-test alone, not mixing that t-test, f-test, and over or so on. So if that is what you want to do, then that is why we need this rempsyc. We already load the package. So again, let's remind ourselves of the names of our variables, because here we have to work with quantitative variables. Don't forget, the t-test is a parametric method of analysis. So names in data cc run. Yeah, so let us have the t-test now. So let's say t-test equals nice underscore t-test. Nice t-test. That's how to do it. So data equals, the name of your data, in data underscore cc, comma, then response. So response equals names, so we have to select necessary variables, names in data underscore cc, then you have square brackets. Oh, sorry, supposed to be here. We have square brackets. Comma here means column. And since I would like to select many columns, let's say C, just the numbers of the variables. So let's say, but just pick the quantitative variables. So we have sales is 1, 2. That's 2, comma. We have employee, that is 10. We have cost of material, that's 13. We have labor productivity, that is 13, 14, 15. And we have 16, which is capital. So let's say this is what we want, comma. Then you have group, is email. That is, t-test is for two independent samples. So use of email, no use of emails. That is why we have the group. Email. Beautiful. Then if you don't want all the warnings to be, because it comes with a lot of warning messages, 1 equals to F. I don't want the warning messages to be published. So let's run this. Yeah. So this is the result. So, and this is what has been calculated is wedge t-test. But if you want student t-test, you just say var.equal equals to true. That's what we add to this one. So now that we have done it, we now have t. Let's get the table. I call it t tab equals the t tab now is the next thing we want to do. You say nice underscore table. So that is get a nice table for t-test. That is this one that we have calculated. So let's have here, because you can actually show it here before you move it to Microsoft Word. Run. So let's say t tab. Run it. Going to generate. Yeah, you can now see. So it's clearer here. You can even see the confidence interval. You can see the difference in the values. These are the various p values. So if you look at it now, the only variable that is insignificant is the labor productivity, which means for all the other variables, there is clear differences between users of email and non-users of email. There is differences in their sales, differences in the number of employees, differences in the material cost, differences in the capital, but there is no differences in their labor productivity. It's super clear. And you can move this to Microsoft Word. Very simple. This is why we have the flextable. So let's say save as, is it save as doc. So T tab, comma. Then in this case, you use path, not file. So path equals, let's say I want to see what I'm typing. Path equals, call it T tab. Sorry, it should be in quotes. T tab dot docx. Very clear. So run it. Beautiful. So again, let's go to file. T tab, T. This is it here. Just open it. Yeah. So I think this is neater if you just want to present the t-test alone. So I think which is for as many variables as for multiple variables, but the quantitative variables. I think this is a clearer way of depicting the result of the t-test. All right, and that takes us to correlation analysis. Correlation analysis. So let's move to correlation analysis. So correlation analysis. So correlation analysis. Correlation analysis. So for correlation analysis, we need library ggstatplot. Sorry, I don't think we included it in the packages when we started. That's why I have to bring it here. So ggstatplots. Again, let's remind ourselves of the names of our variables. Names in data underscore cc. So run it. Yeah, let us look at let's select the variables that we will need. So let's call the data core data, that is data we need for correlation analysis, equals, we need it, we have to get it from in data cc. Then we have percent, greater percent. We have now seen the use of select again. So select, let's select, because you need the quantitative variables actually. You don't use correlation analysis for all this qualitative information. So let us select variables. Let's say we have sales, we have labor, no, employee. I often forget that we have changed this to employee. Let's say we have capital. Let's say we have mat costs. Yeah, and let's say we have our LP. Yeah, let's bring all of them. So let's say this is just what we want. Then let's run it. Good. So it's ggpubr, that is the function. ggpubr. So we have core data we have generated. So run it. Beautiful. Now the beauty here is that it's going to put a cross on insignificant variables. So in this situation now, the correlation coefficient between sales and employee is 0.4. So which shows a positive relationship, though not very strong. For cost of material, cost of intermediate input and employee is 0.51, which a slightly strong relationship. Yes, capital and material costs, as expected, they are positively related, but the relationship is weak, and so on. So, and you can look at labor productivity and employee, labor productivity and capital, labor productivity and cost of intermediate input. So this is how to handle it. When you may change the position of the matrix, say matrix, sorry, that would be matrix type. So it's either lower or upper. So let's say lower. Let's run it. Yeah. So the previous one was upper, so it's either you have it this way or that way, depends on you. So it's your choice. Yeah. So chi-square analysis, that's the next thing we want to quickly look at. Chi-square analysis. Yeah, this is, we are doing this for the chi-square analysis. If you just want to do it separately instead of using ASNA, but usually for publications, I think it would have been better for you to just use the ASNADENS, because it's going to give you the overall summary. But if you want to do it one by one, depending on you, particularly maybe you are a master or PhD student and you are expected to perform all these analysis and show them in details during your presentation, I think definitely you will need this type of analysis. So is the function is ggpubr stats. ggpubr stats. So we are in data underscore cc, comma. So you define your x. So let's say my x is web. Don't forget, I've changed this to web on. And my y is equal to frame size. Don't forget, we normally use chi-squared to look at association between qualitative variables. So is frame size. All right. So let's run this and see and look at the results. Yeah, beautiful. So you can see the results here. You can see the results for ownership of website. You have yes or no. And for landscape, 64% of them were using half websites, own websites. For micro, very minute percentage that is expected. For small, we have about 17% of them and so on. So this is actually showing a very clear variation in the use of websites by various categories of firms. And you look at piercing. Our interest is actually this p-value. You check this 0.0000 because you can see it's 1.9 multiplied by 10 to the power minus 69. That's 0.000 something. And since it's far less than 0.05, even 0.01, so we can conclude that it's a very strong relationship, very strong association between the size of the firm and ownership of websites. And we can now go ahead and explain all this variation that we have in the data. So, and that takes us to regression analysis. Regression analysis. Regression analysis. Let me quickly show us a few things here before, so that we have a quick review of all the basic with respect to correlation and regression analysis. When we talk of correlation analysis, we are describing a bivariate relationship between two variables. If you look at the matrix generated, we're actually looking at two variables at the same time. There are two types. We have the Pearson, which deals with the parametric. Then we have the Spearman, which deal with non-parametric. And the value always ranges between -1 and 1. A value of near or equal to 0 implies little or no linear relationship. You can see, in that correlation result that we had, one of the values in the boxes were actually crossed, mark X, showing that there is no relationship. If you look at the value, it's very, very small, very close to 0. In contrast, the closer to 1 or -1, the stronger the linear relationship. It is very close to 1, that is positive, that is strong positive relationship. Very close to -1, strong negative relationship. By negative relationship, we means as one is rising, the other one is decreasing. But if both of them are moving in the same direction, one is rising, the other one is rising, then we talk of positive relationship. And let me spell out this mathematics of how to obtain the test. So that's what I want you to quickly understand. So there are various relationships, and for regression analysis, we can classify into two. We have simple and multiple. Simple means we just have two variables, one independent, the other one dependent variables. The variables whose value we are trying to obtain is the dependent, and the exogenous variables that we are trying to use in order to sort out the value of that variable is what is called the independent variable. When we are dealing with more than two, that is maybe peradventure you have one dependent and several, that is more than one independent, and we are dealing with multiple regression analysis. For simple, you can have it in terms of linear and non-linear, for multiple linear and non-linear forms. Yeah. And in terms of what we are trying to do, this is the basic ideas about regression using this simplest form of linear regression. You see, usually we have our observed y, that is our dependent variable. Then we have our observed independent variables. We have the values for various respondents of various firms, just as we have in the data sets that we have. And but we do not have sufficient information about these error terms. When we talk of error terms, it means we have some vectors or variables that might influence this dependent variable that we have not included. And even for those that we include, it's likely we have quite a lot of measurement errors and kind of problems. So, and to capture this, we use quite a lot of assumptions. So, and this is what we are trying to do. So, these are the various values of x6. So, and the distance between this and this regression fits is the error term. You can see this distance is positive, this distance is negative, and we believe that one of the assumptions is that the mean is supposed to be 0. But by and large, in regression analysis, what we're trying to minimize is the square of this error term. We square it because of the negative. Now, when you square negative, it becomes positive. So we are actually looking for the least error term. Yeah. So this is what we eventually arrive at. We estimate our y based on the value. So the main values of interest will be these intercepts as well as these slopes. So, and in terms of interpretation, which I want you to please pay attention to, the intercept is the estimated average value of the dependent variable, which is y, when the value of your independent is 0. The slope is the estimated change in the average value of your dependent variable as a result of a 1 unit change in your independent variable. I think let's stop there and go back to our R. So we are going to start with simple regression. Simple regression. Let's say our interest. Let's say our interest is simple regression. Let's say our interest is sales versus label. That is our interest. So we can actually use scatter diagram in order to explain what is happening. So let's say library ggpubr, ggpubr. So for ggpubr, this is what we will have. So we have let us convert, let's say in data underscore cc before we move forward. Let's say dollar, let us get a new sales, let's say sales 2 equals, I will explain the reason why I'm trying to do what I'm trying to do. Is equal to in data underscore cc dollar sales, just pick sales, divided by, let me move this, divided by 1 million, because the values are very large. The value is very large. The value is large. The value is extremely large. So we generate another variable which is sales2, and the value is extremely large. That is why we say let us divide by 1 million. Yeah, okay. So let's run it. That's another way, or you can actually use the approach we used before in terms of mutate to do it. But I think since we are dealing with just one variable, I think this is another method we can use. And that takes us to ggScatter. So we have ggScatter. This is the function we need to, so we have in data underscore cc. So we have x equals to, our x in this case is employee. I don't want to make the mistake because we have actually changed it to employee. Then our y, in this case, now let us use the new variables that sales2, yeah. So let's move it here, and so run. Yeah, you can now see a lot of scatter plots here and there. Then we can, let's say color equals, let us use the frame size as the color. Frame size as the color. Run. Now it has distinguished the frame size by the color, using the frame size large, micro, and small, so you can get which frame belongs to this point, which frame belongs to this point, and lots more. So, and again, we can label it. So let's say label. So label equals let's say frame size. Frame size. So if you label it, run it. Yeah, good. So it's actually showing the label in a clearer manner. So we can add the regression line. Let us add the regression line. So let's say to add the regression line, just say add equals is reg dot line, reg.line. That is what you need to add. So let's run it. You can see. So that's the regression line. We can add the regression equation. So if you want to add the regression equation, okay, if you want to add the regression equation, we come out here and say plus. We have stats underscore red line equation. Yeah, so you can run it. So this is the equation. So we can see that the sales is actually moving at, don't forget it's 52 million because we divided it by so if you employ one more labor, then this is the rate at, this is the unit with which your sales will increase. Then another thing we can add, so we can add the start plots. Okay, even before this, we can come here and say star plots. That's what we call star plots, so that it's going to direct us to different outliers. Let's say star plot equals to true. Yeah. So if we have this run, yeah, it's now pointing us to different outliers. Even then, we can even have better color by adding palettes. My favorite in this case is JCO. So let's run it. Run. Yeah, so you can see quite a lot of changes that you can introduce. But if you want to run the regression, I mean, it's so simple to do. Just go ahead and let's say we are running a linear model, so this linear equals lm is the function. Then we have sales 2 in this situation. Then we have as a function of employee, comma, then we have our data equals in data underscore cc. So we can have the summary. So summary, linear, beautiful. So run. Good. So can now see clearly. So, and you can export your data, stargazer, linear, comma, type equals h, that's HTML, then you have out equals, let's say reg1 dot doc. So that is it. Let's round up in case you want this linear regression. I mean simple, but for multiple, it's so simple too. So let's say multiple regression. So this, what you just need is to add more variables here. So let us add, we have employee. What should we add to it? Can add any. So let's add capital, then plus mat costs. All right. So, and let us add M here. So I run it. Beautiful. So again, you have summary, M linear. So run it. So beautiful. Yeah. So in this situation, just two of the variables are significant, employee and mat costs, and a 1 unit increase in employee, that is, we employ more labor, then this is the increase in your output. If you had more material costs, then this is what will happen to your output. It's going to increase too. Yeah. So, and you can export it also to Microsoft. This is copy to Microsoft Word, and that is the last thing we'll be doing. So linear, so let us add M linear, comma, so and let's say this is rec2, and let's run it. So beautiful. So let us look at the last results. So yeah, we have reg. So this is rec2 result. So this is the result. Yeah, beautiful. So you can see the beauty of it. So we have, this is the model when we have not included the other one. This is the linear. This is the multiple regression. These are various results. So this were the convenient place to stop. In the next class, hopefully, we'll be doing more. Thank you